I'm Anil Kumar. Welcome to my series on functions. In this video, we'll learn few basic concepts about function notation, its advantages, take up some examples, followed by a practice test. Now, before we begin about function notation, let us also see the questions which we need to answer. That will give us an idea about what we will be covering in this about half an hour video. Question number 1 here is, which of the following statements are correct about this given function f of x equals to minus x squared plus 1, and we need to justify our answer. Now in these 4 parts, more than one can be correct. So look into these options, try to solve this question, and then see the next one, which is, think about a number n multiplied by 4 and then subtract the product from 20. Now multiply the resulting difference by the number first thought of. Use function notation to write answer in terms of n. Now this is a very common question, and you could be given different set of rules to define a function. Right? Question number 3 is, find an expression for f of a minus 1 if f of x is given to you as minus x squared plus 1. Right? Question number 4 is, given g of x equals to 1 plus 6x minus 3x squared, find a so that g of a is equal to 6a minus 74. Question number 5 is, if f of x equals to x squared plus 5x plus 3k and f of k equals to minus 16, find f of 3. Question number 6. If f of 5a minus 1 equals to 15a plus 1, find an expression for f of x. Now this is a thinking question, not easy to solve. Question number 7 is a word problem. A car rental company rents 300 cars at a cost of $30 per car. For every $3 increase in cost, company rents 10 fewer cars. If x represents the number of increase in cost, which of the following function best describes the revenue function r of x? Question number 8 is, find the point of tangency of the line with the slope equal to 4 to the parabola y equals to 0.5 x squared plus 2x minus 8. This is an extremely difficult question, so I'd like you to concentrate and then answer this particular question. Now we have two open response questions. Question number 9 here is, given f of x equals to x squared minus x minus 5, find if f of n equals to 7, find the value of n. And question number 10 is, let f of x equals to minus x squared plus 1 and g of x equals to 1 over f of x. Write domain of g of x, find interval when g of x is greater than 0, determine the points where g of x equals to f of x, sketch the graph of the function g of x. So I hope you find these questions interesting and useful. We'll actually begin with our discussion on functions notation now. As you see, on this particular coordinate plane, we have shown 3 different curves. One is a straight line, which is a horizontal straight line in green, where the value of y is 1, 2, 3, 4, right? So 1, 2, 3, 4. So the value of y is 4. So the horizontal line, which has been shown like this, we could write the equation of this line as y equals to 4, right? Now let's look into the other curve, which is a parabola opening upwards. Now this parabola opening upwards has a vertex at 1, minus 1, and therefore we can write this as x minus 1 whole square, and it has gone 1 unit down, so it is minus 1. So that is the equation which will describe us the parabola. Then we have some scatter plot. All these dots are in a straight line, which could be written as y equals to x. Now, since these are the dots which are not connected, here we know that x actually belongs to integers, and the value of x is between 1, 2, 3, 4 negative to 3 positive, right? So we can write here that the value of x is from minus 4 included, right, to 3. The earlier ones were connected, and therefore we could write them as the value of x belongs to real numbers for the first one, and also for the next one, x belongs to set of real numbers. Correct. So we have 3 different graphs, all described by y equals to something. Now, when you are working with more than one function on the same coordinate plane, now y equals to 4, y equals to x minus 1 whole square minus 1, y equals to x creates a confusion. Sometimes we don't understand which particular curve we are referring to when I say find the value of the function at x equals to 1. Now, we don't know which function we are talking about, right? So therefore, it is good practice to provide a name, right? So basically, the idea of function notation is basically to provide name. So that is to give a name. Now this name helps us to communicate better. So each one of these could be given different names. We could call the first one as, for example, we can say, let that be f of x equals to 4. The second one, let's give the name as g. So g of x equals to x minus 1 whole square minus 1. And let's say h of x equals to x. So now we have 3 different functions. We have given them names, and we are calling this function as f of x. The second one, which is a parabola, we are calling this one as g of x. And the third one, we are calling this as h of x. Now you will notice that if I write f of x, g of x, and h of x, I'm very sure you will understand which particular graph we are referring to. Perfect. Not only that, with function notation, we have many other advantages. Another very important thing is we could actually work with these functions in a different way. We can say, what is the value of the function at a particular point? So if I write what is g of 1 equals to, that really means what is the value of function g at x equals to 1. So when I write g of 1, it means value of function g at x equals to 1. Correct? So what you notice from all this is that y, the dependent variable, so basically what you saw here is that the dependent variable has been replaced by the function. Normally we write f of x. You understand, correct? So dependent variable has been replaced by f of x. So f of x is basically equal to y. Right, so y is normally replaced by f of x in function notation. Is that clear to you? Right. So whenever we define a variable, f is the rule. So now we can say that in general, f is the rule, right? And to this rule, we are giving some inputs and getting some output. Input in this case will be x, and the output will be f of x. So y, which you were earlier using in your equations, will now be replaced by f of x. So f of x is the value of the function for a given input, and f itself is the name of the rule which the function follows. Is that clear to you, right? And now clearly you can see a lot of advantages. One is we can refer to each function by its name and communicate better. We can also do some operations with the function using this notation. For example, now if I know f of x is 4, we can also find what is x plus 2. F of x plus 2 equals 2, correct? Similarly, we can work out what is g x plus h equals to. So we can actually work with these functions better, right? That's the whole idea. So function notation helps us to communicate better and work with the operations of the functions in a more meaningful way. Is that clear to you, right? Well, now let us solve these multiple choice questions. Question number 1. Which of the following statements are correct about the function f of x equals to minus x squared plus 1? Justify your answer. Now, with the help of these 4 examples, we'll understand more about function notation. A. F of minus 1 equals to 2, right? So when you read this, we really mean the value of the function at x equals to 1 minus 1 is 2. That is what we mean. So when we write f minus 1 equals to 2, you should read this as f of minus 1 is 2, right? So that is how you should read, and it means what? It means value of function at x equals to minus 1 is 2, right? So that is what function notation is, right? Now how do you check the answer? We are saying f of minus 1 equals to 2, and that really means that value of function at x equals to minus 1 is 2. The question is whether this is correct or not, right? We need to justify. So what we can do here is substitute minus 1 for x, right? So this basically means that we'll write f of minus 1 really means substitute minus 1 for x. So we have minus of minus 1 square plus 1, which is minus 1 square is positive, so we get minus 1 plus 1, which basically is 0. So this statement, as you've seen, it is not 2, but it is 0. So since f of minus 1 equals to 0, this is false. Is that correct? Which of the following statements are correct? So this is not correct. Second, f of k equals to minus 3, then k is minus 2. So now, to answer part B, what should we do? When we say f of k is minus 3, then k is minus 2. So what we are trying to say here is that we are saying that f of minus 2 is minus 3. That is what we are saying, right? F of k is minus 3, then k is minus 2. So now, let us substitute minus 2 here. So if I substitute minus 2, I get what? I get minus of minus 2 square plus 1. Minus 2 square is 4. So you get minus 4 plus 1, which is 3. So this is true, correct? Therefore, we'll circle this. So that is correct. Is that clear to you? So in the first 2 parts, you understand how to evaluate a function using function notation. Clear? C. The point P, 3 minus 8, lies on f of x. That also means kind of same thing as we did before. That means if I substitute 3 And if I get minus 8, then it is true. So we'll now substitute 3 here, right? So let's find what is f of 3 equals to. So when I substitute 3 here, I get minus of 3 square plus 1. That is minus of 9 plus 1, and which is indeed minus 8. So this is also correct. Perfect. Part D is line y equals to 0 intersects the parabola f of x at 2 points. Now, is that true or not? Well, let's try to sketch and then see our solution. Well, minus x squared plus 1 will be a parabola which will be kind of like this, right? Where this point is plus 1, right? When I say line y equals to 0, now what is line y equals to 0? Y equals to 0 is x-axis. So this particular line, which is x-axis, is y equals to 0. At every point, the value of the function is 0, right? That is y equals to 0. And it does intersect at 2 points, right? So it says line y equals to 0 intersects parabola f of x at 2 points. That is correct. So this is also correct. So in question number 1, we have 3 correct statements. Perfect. Let's move on and take question number 2 now. Think about a number n multiplied by 4 and then subtract the product from 20. Now multiply the resulting difference by the number first thought of. Use function notation to write answer in terms of n. 4 options are given to you, right? So let's think about a number. Let's say we think about the number is n. Then we say multiply by 4. So it becomes 4n, right? So that is the next statement, which is times 4, right? And then subtract the product. So this is the product, correct? From 20. So when we say subtract from 20, that means it is 20 minus 4n, right? So we have subtract from 20. Right? Now multiply the resulting difference. So this is the difference, right? This will be referred to as difference. Now multiply the resulting difference by the number first thought of. Number first thought of was n. So we need to multiply this by n. So we get n times 20 minus 4n. Clear? That's what it means, correct? So this becomes our function. We have to write this using function notation. Function notation, give it a name. So in the answer we given f, independent variable is n for us, the number which you think about. So f of n becomes equal to this. However, we have it in expanded form. So let's open the bracket. We get 20n minus 4n square as our answer. So 20n minus 4n square is option B. So that is the correct option. Is that clear to you? So many times we are given statements or word problems and we can make an equation and write it in function notation just as shown here. Here is question number 3. Find an expression for fa minus 1 if f of x is minus x squared plus 1. Right? So see, we can communicate much better with functions using function notation. So we have f of x equals to minus x squared plus 1. We need to find an expression for f of a minus 1. So replace x with a minus 1. So get minus of a minus 1 whole square plus 1. So what is perfect square? A minus 1 whole square equals to? Well, let's write it in bracket. A square minus 2a plus 1 square, which is 1 plus 1. Now open the brackets. Minus a square plus 2a minus 1 plus 1. Now minus 1 plus 1 is 0. So we're left with minus a square plus 2a. So which is option B for us, correct? So we got option B as the correct answer. So I hope it is perfectly fine. So what you learned here is some basics about function notation. Now, we have some interesting questions coming up. Question number 4. I'd like you to pause the video, answer this question, and then look into my suggestions. Question number 4 is, given g of x equals to 1 plus 6x minus 3x squared, find a, so that g of a equals to 6a minus 74. Well, g of x and g of a really means that you substitute a here. So we get g of a as equal to, substituting a, we get 1 plus 6a minus 3a squared. Replace x with a. But we are given that g of a is 6a minus 74. So we'll write this as 6a minus 74 equals to 1 plus 6a minus 3a squared. Now let's bring the variables on one side, numbers on the other. So we get 6a minus, so this is also 6a, and that minus becomes positive 3a squared, where 1 here brings 74 on this side. So 6a minus 6a is 0, so we get 3a squared equals to 75, a squared equals to 75 divided by 3. So we get a, which is, let's write a squared as 25, 75 divided by 3. So a is equal to square root of 25. Now whenever you do square root, remember to do plus and minus. So we get two answers here. One is minus 5, the other one is plus 5. The options include minus 5, so we'll select that as our right answer. Is that clear to you? Perfect. Question number 5. If f of x equals to x squared plus 5x plus 3k and f of k is minus 16, find f of 3. Very interesting question. I'd like you to pause the video and answer this question. So what we're given here is that f of k equals to minus 16. But f of x is x squared plus 6x plus 3k, right? So we could write this in terms of f of k, replacing x with k. We get k squared plus 5k plus 3k. Now we have only one variable. We can actually figure out what this variable is. K, that is. So we get minus 16 equals to k squared plus 8k. Bringing this to the right side, we get 0 equals to k squared plus 8k plus 16. So from here, we could actually factor, it is a perfect square, so we could write this as k plus 4 whole square, right? So that really means that k should be equal to minus 4. Only then you get 0 here. So we first find the value of k, which is minus 4. Substituting this value k in our function, we know that f of x should be equal to x squared plus 5x plus 3 times minus 4, right? So which is x squared plus 5x minus 12. So the function now is x squared plus 5x minus 12. We need to find the value f of 3. So we'll just plug in 3 for x. So f of 3 equals 2. Substitute 3 here. 3 squared plus 5 times 3 minus 12. So get 9 plus 15 minus 12. So 12 minus 15 minus 12 is 3. 9 plus 3 is 12, right? So, or you can say 24 minus 12. We get option D as the right option. Clear? So that is how we should be solving this type of question. Now comes another thinking question, question number 6. If f of 5a minus 1 equals to 15a plus 1, find an expression for f of x. 4 choices are given to you. You can actually pause the video now, work out a strategy to figure out this answer, right? And then look into my suggestions. So the question here is, if f of 5a minus 1 equals to 15a plus 1, find an expression for f of x. Now, how do we do that? Well, here are some steps which you could adopt to solve such a question. So what we will do here is, we know 5a minus 1, we want to get to 15a plus 1. So let's look into it. See, we have 5a minus 1. Now, if in first step, I kind of multiply by 3, then what do I get? I get 15a minus 3. So times 3 gives us 15a minus 3, but we need 15a plus 1, right? So how do we get 15a plus 1? Well, we could get plus 1 if I add 4 to it, right? So if I add 4 to it, then what do I get? I do get 15a minus 1, right? So we get 15a plus 1. So minus 3 plus 4. So the operation performed is these two operations. Do you see that? So that clearly indicates that the function f of x could be written as 3x 3 times, treat this as x, right? So it could be written as 3x and then plus 4. Does make sense to you? And we have that option as option C, and that is how we could get our solution. So this is probably the simplest way of solving such questions. So this is a very tricky question otherwise. Here is question number 7. This is a very popular word problem. You'll see many times similar examples. A car rental company rents 300 cars at a cost of $30 per car. For every $3 increase in cost, the company rents 10 fewer cars. If X represents the number of increase in cost, which of the following functions best describes the revenue? Now, revenue is basically equal to cost, or you can say price, times the number of cars sold, right? Or in this case, rented, I should say. Cars rented. So that is going to be the revenue in our case. It's a rental company, right? Okay. So initially, for $30, the company can rent 300 cars, correct? Now, if we increase by $3, that means if I do plus 3, cost instead of 30 is plus 3, 10 fewer means minus 10. Do you understand? If I do increase it by $6, that means 2 times 3. In that case, the cars sold will be less by how much? Well, for every 3, 10 less, so it will be 2 times 10 less. So what you see here is that as we increase in multiples of 3, the cost, the rental cars number decreases as multiples of 10, right? So that gives us an idea that the revenue could now be written as 30 plus, this is n in general, right? So n times 3, we can say x, which is a variable used here. So let's say x, okay, let's write this as 3x. I'm writing this number as x, our variable, since we are talking about x as our independent variable. And the number of cars rented will be 300 minus 10x. Now it's good practice to write the numbers first and then the variable, and that is why it is written like this. So 30 plus 3x and 300 minus 10x becomes the solution. So it is option D for us. Is that clear? Question number 8. Find the point of tangency to the line with the slope equal to 4 to the parabola y equals to 0.5x squared plus 2x minus 8. 4 options are given to you. You can always pause the video, answer this question, and then look into my suggestions. The question here is, find the point of tangency of the line with the slope equal to 4 to the parabola y equals to half x squared plus 2x minus 8. Now 3 points are given to you to test it out. You can always pause the video, answer this question, and then look into my suggestions. So basically, let's try to understand it. We have a parabola which opens upwards, so it will be kind of like this. And a line which is tangent has a slope of positive 4. So it is on this part of the parabola. So say it like this, right? When we say find the point of tangency, it means this particular point where this line is tangent, right? That's what we need to find. So let this point be xy. So what you see here is that the point lies on the line and also on the parabola, and it intersects only at one point. So those are the two critical things which you understand. So the critical things which you need to figure out here is, one, that the p xy is common to the parabola and the line, right? One. Second point is that if you think about system of equations, right? So the parabola and line intersect only at one point. So that is tangent, right? So that is called point of tangency. So that is the other thing which we understand. Now with this in mind, I think you should be in a position to answer the question. So I'd like you to now pause the video, answer this question, and then look into my suggestions. Now to solve this, what we should do is, we already have the equation of the parabola. As far as the line is concerned, we can say the equation of the line can be y equals to 4x plus some constant k, right? We really don't know what this constant is. We know slope is 4, right? So slope is equal to 4. So y equals to 4x plus k is the equation of the line. Since it intersects at one point, that means we could, at that point, both y values will be same. So we could say 4x plus k should be equal to 0.5x squared plus 2x minus 8. Now here we can solve this quadratic equation. So we get 0 equals 2. Taking this on the right side, we get 0.5x squared plus 2x minus 4x minus 8 minus k, right? Well, so basically we could write this as 0.5x squared minus 2x minus 8 minus k. So that becomes our quadratic equation to solve. How do we find k? Now in this, we'll use our strategy, which is that the line intersects only at one point. So that means, let's recall that if you have a line y equals to ax squared plus bx plus c, then b squared minus 4ac should be equal to 0 for one point of intersection, or the condition for tangency. Is that correct? So we'll use this particular concept to solve further. So now we are saying that b squared minus 4ac. So in our case, b is minus 2, right? A is equal to half, which is 0.5, right? And c is equal to minus 8 minus k. So b squared minus 4ac, which should be equal to 0, can now be written as minus 2 squared minus 4 times a is half, which is 0.5, times c, which is minus 8 minus k. That should be equal to 0. Perfect. Now, minus 2 squared is 4, and this is 4 half is 2. So we could write this as minus 2 times, well, you may write minus 8 minus k for now, right? We can now bring it to the other side and then figure out the value of k, right? It can be easily solved. So we have 4 equals to 2 times, this is minus 8 minus k. So 2 equals to minus 8 minus k, and k will be equals to minus 8, and bringing down 2 to this side, we get minus 10, correct? So the value of k is minus 10. Now once we get the value of k, we can actually get the point also, right? So k being minus 10, we will now write in our equation which we had minus 10 and then solve for it, right? So now we have 0 equals to 0.5x squared minus 2x and minus 10. So that is minus 8 plus 10, correct? Minus and minus. Okay. So we get our equation as 0 equals to 0.5x squared minus 2x, and that is plus 2, right? Now, from here, we could take half common. So we get 0 equals to half common. This is 0.5 x squared minus 4x. This is plus 4, correct? Now that can be factored. So we get 4 times. This is 2 square, right? So we can write x minus 2 whole square, and that gives you x equals to 2 as our value. Well, we do have a value for x equals to 2. The only thing is we need to figure out, if I write 2 here, what do I get? Okay? So let's find the value of y when x is 2. Right? So that's the whole idea. So we can substitute 2 here and calculate. So we get y equals to, substituting 2, which is 0.5 times 2 square plus 2 times 2 minus 8, right? So that is 4, half of 4 is 2, plus 4 minus 8. So 6 minus 8 is minus 2. So we get 2 minus 2 as our solution. Is that clear to you? So that is how we are going to solve this particular question. Now this is extremely important question, slightly difficult at this stage, but I hope you've understood the solution. The whole idea here is that since we are given the slope 4, we can say that the equation of the line should be y equals to 4x plus k. Now, to find the value of k, we know that they intersect only at one point. So, equating the y values, we get a quadratic equation, and this quadratic equation should satisfy the condition b square minus 4ac equals to 0. Only then we have only one point of tangency, right? Since this is 0. So substituting that, we could solve for a value of k. Substituting k back into our equation, we got the value of x. It's kind of tricky. So I hope you've understood all the steps. We are almost at the end. Here is question number 9. Open response question. Given f of x equals to x squared minus x minus 5, if f of n equals to 7, find the value of n. So we are given f of n is 7. So f of n really means replace x with n, right? So we get n squared minus n minus 5. Now this is given to us as 7. So we write 7 equals to n squared minus n minus 5. Bringing 7 to the right side, we get 0 equals to n squared minus n minus 5 minus 7, or n squared minus n minus 12. Now, 12 has a product and sum 3 and 4, right? So we could write 12 as product of 3 and 4. Since we want negative to add, so we get minus 4, right? So we could write this as n minus 4 times n plus 3. Clearly, n could be equal to 4 or n could be equal to minus 3. So there are two solutions for this particular question. So we get answer as n is equals to 4 or minus 3, correct? Now the last question for us is question number 10. Let f of x equals to minus x squared plus 1. G of x is 1 over f of x. Write domain of g of x. Find interval when g of x is greater than 0. Determine the points where g of x is equal to f of x. Sketch the graph of the function g of x. Now, g of x is reciprocal of f of x. F of x is in the denominator. So, as far as g of x is concerned, to find the domain, what should we do? Well, for finding the domain, we should know that f of x should not be equal to 0, right? So those are the restrictions. Otherwise, all values of x are permitted, right? So that is our restriction. So let's figure out when is f of x 0. So we are given f of x equals to minus x squared plus 1. Now this is 0. Let's find when, right? So that's the whole idea. So that gives you x squared equals to 1, x equals to plus minus square root of 1. So we get x equals to plus minus 1. So since x equals to plus minus 1 results into 0 value of f of x, we can write restriction that x is not equal to plus minus 1, correct? Now, the question was really to find the domain, right? So we can now write the domain as, what? So domain of g of x is x belongs to real numbers where x is not equal to plus minus 1. Clear? So that is how we are going to write the domain. Part B is find interval when g of x is greater than 0. So greater than 0 means positive, right? So let's be very clear. So when I say g of x is greater than 0, means positive, correct? It also implies that f of x should also be greater than 0. Is that clear to you? Right? F of x should also be greater than 0. Now we found that f of x is equal to 0 at plus minus 1. So if I try to sketch this parabola, it will be like what? It will be parabola opening downwards, correct? Clearly, this value here, when I substitute 0, this is for f of x, is 1. These values are minus 1 and plus 1, correct? When I say g of x should be greater than 0, f of x is positive, that means what is the interval? Well, it is between these two values, correct? So find the interval when g of x is greater than 0. So the interval in this case should be from minus 1 to plus 1, both not included. Clear? So in this interval, g of x is going to be positive. C. Determine the points where g of x is equal to f of x. Now we want to figure out when is g of x equal to f of x. Well, clearly, it means both are equal to 1 or plus minus 1. Is that clear to you? So from here, we see that the both are equal to 1 at x equals to 0. That is one point. And when are they equal to minus 1? So somewhere here, both will be minus 1 also, right? So one point definitely is this point, right? The other point should be when both are minus 1, right? So let's figure out when is the function minus 1. Clear? So now we'll calculate for f of x equals to minus 1. So minus 1 equal to minus x squared plus 1. So that means x squared is equal to 1 plus 1, which is 2. So x is equal to plus minus square root of 2. So that clearly shows that for C, determine the points where g of x equals to f of x, we have three answers. It is when x is equal to 0, because then it is 1, or it is equal to plus minus square root of 2. Is that clear to you? So that becomes the solution for part C. And now, the last question here is, we need to sketch the graph of g of x, right? So let's sketch the graph of g of x. Okay, so I'll sketch it here. So we are trying to sketch the graph of g of x now. So at 0 it was 1, so we do get a point which is at 1 on g of x. Now at minus 1, x equals to minus 1 and plus 1, zeros are there, so we have a vertical asymptotes here, correct? So these are the vertical asymptotes which we are going to have at x equals to 1, right, and at x equals to minus 1. So these are the two vertical asymptotes. Since 1 of 0 is not permitted, it is not in the domain of the function. Now, as the function decreases, the inverse should increase, right? So therefore, if you are approaching towards 0, reciprocal will increase, so you have a graph which will be going upwards here. On the other hand, we saw if it is negative and then going very high negative, it will be going 0. So somewhere here the graph will look like this. And we know that at square root plus minus square root 2, the value of the function will be negative 1. Is that clear to you? So that is how we could actually sketch our function g of x. Perfect. So with this, we come to an end of our video. I hope you understand the basics about function notation, and these 10 examples provide you with some insight to what type of questions you should be ready with, right? So I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Thanks for watching and all the best.